Assalamualaikum warahmatullahi wabarakatuh. My name is Khairul Aiman bin Abdul Kahar. My metric number is B04-201-0277. I'm from group Thermocirculation. So our group is discuss about thermodynamic analysis of an absorption refrigeration system.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hafiz bin Ahmadi and I am from group ThermoCirculation. Okay, today we will explain about the absorption refrigeration system. What is absorption refrigeration system? It is the vapor absorption refrigeration system comprised of all the process in the vapor compression refrigeration system like compression, condensation, expansion, and evaporation. Later, my friend will explain more detail about the compression, condensation, expansion, and evaporation. In the vapor absorption system, the refrigerant use ammonia, water, or lithium bromide. This is the substances that can be used. The refrigerant can get condensed in the condenser and it get evaporated in the evaporator. The refrigerant produce cooling effect in the evaporator and release the heat to the atmosphere via the condenser. The major difference between two systems. It has two systems, but the process is different. First, the system is suction and compression of the refrigerant in the cycle. The compressor sucks the refrigerant from evaporator and compress it to high pressure. The compressor also enables the flow of the refrigerant through the whole refrigerant cycle. The second system is the vapor absorption cycle. First, the process of suction and compression are carried out by two different devices called as the absorber and the generator. Second, the absorber and the generator replace the compressor in the vapor absorption cycle. The third, the absorbent enables the flow of the refrigerant from the absorber to the generator by absorbing it.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Khairul Aiman bin Abdul Kahar. Today, I want to discuss about schematic diagram of aqua ammonia system. Okay, first, we have a generator absorber system as replace the compressor. Ammonia is mixed in the absorber in cold water, so it is highly soluble in cold water. By the help of pump, since it is strong solution is sent to generator. In generator, heat is supplied and ammonia is liberated from the cold water with high pressure. This high pressure ammonia sent to condenser. Ammonia loses its latent heat to atmosphere and become liquid because vaporization. Then it passes the aeration valve and the pressure again reduced and ammonia reach evaporator. It absorbs the latent heat of vaporization and become vapor. Evaporator region cools because it is absorbed latent heat of vaporization. So this system will develop higher amount of refrigeration effect using low energy. That's all. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Muhammad Firdaus bin Saimi. My metric number is B04-2010253. Thank you to my fellow friends and my lovely doctor because give me opportunities to explain more about the performance and calculation in the refrigeration cycle. Okay, first of all, I would like to explain to you about the performance of the process. Okay. First, at the point 1 to point 2, the process is called isentropic compression. At the point 2 to point 3, the process is called constant pressure heat rejection. And at the point 3 to point 4, the process is called throttling in expansion device. And the last process is called constant pressure heat absorption that occur at the point 4 to point 1. Okay, next I would like to explain to you about the formula that we use in the refrigeration cycle. Okay, for the heat transfer is equal to QL equal to specific enthalpy at point 1 minus by specific enthalpy at point 4. This specific enthalpy we can find through the thermodynamic table based on the temperature or the pressure that was given in the question. Basically, in the question, they will give us temperature or the pressure. So don't worry, we can find the specific enthalpy. Okay, next I will explain to you about the formula word. Word input equal to specific enthalpy at point 2 minus by specific enthalpy at point 4. For the throttling, specific enthalpy at point 3 equal to specific enthalpy at point 4. And the performance is COP equal to QL divided by word input. First of all, we need to increase the evaporator pressure. When we increase the evaporator pressure, the refrigerant effect also will be increased, but the word input will be decreased. The COP also will be increased because of the formula COP is refrigerant effect divided by the word input equal to COP. When the refrigerant effect value is higher than the word input, so the value of COP also get higher. As we know that when COP get higher, the operating system for the refrigeration cycle will work efficiently. So the cost for the operating system will get lower. Okay, next we need to decrease the condenser pressure. Same like before, refrigerant effect also will be increased, but the word input will be decreased. The COP will be increased because of the RE also increased, and the cost is lower. Next is superheating refrigerant within evaporator. The refrigerant effect also will be increased, the word input will be decreased, and the COP is increased. And lastly, the subcooling within refrigerant. The refrigerant effect also will be increased, but it get no effect on word input. The COP will be increased, but it will be decreasing when using ammonia as the reference. Okay, that's all from me. Thank you.